All right, good evening, everybody. I hope you're enjoying the Friday evening as it rolls on here at Notacon. I hope you're enjoying the bar carts. I hope you're enjoying the bar carts a lot. You should buy lots of booze from the bar carts. Suter is, I think, personally, single-handedly helping us reach our goal at the bar carts. So, but if you can give him a hand, I'm sure he'd appreciate it. We all know Matt Neely, of course, as the Canadian singer-songwriter who has written and recorded 4 albums and toured widely throughout the US and Canada. We also know, of course, that he's worked extensively with producer Ben Carlstrom and has sung many songs on the Bob Rivers Twisted Tunes albums and Man Cow song parodies. Tonight, he is the Notacon Mythbuster.
I'll try not to break out into song, but some parts of this are better sung. So depending on what strikes me, we might go into a musical mode here just to help liven things up, a little West Side Story, maybe Cats, we'll see. Thanks everybody for coming out today. Today we're going to do a little bit of Notacon Mythbusters, basically looking at the urban legend that data is stored on hotel keys, analyzing that legend using Magstripe analysis tools. Then I'll move into some advanced Magstripe discovery techniques. First, a little spiel about me. Manager of profiling team at Secure State. Basically manage a group of hackers. If people saw Relic or Dave Candy's talk, he's actually my boss. If you look online, you'll find some scary pictures of us. Actually, if you download the recent Security Justice podcast, you'll find a scary picture of us. Areas of experience, do a lot of stuff with wireless, pen testing, physical security, security convergence, all sorts of fun stuff. Spoken at places like ShmooCon, DEF CON. Outside of work, do the Security Justice podcast. If you're looking for a new podcast to tune into, check out Security Justice. Also help run the New InfoSec forum. If anyone's a local person looking for a security group, look up the New InfoSec forum on the web. It's a free security group that I help run in town. Great resource. With that, basically, today we're going to look at this email, which you might have seen in different forms, basically stating that personal data is stored on hotel keys, that your credit card number, home address, name, all different information is stored on hotel keys for when you check in, and therefore you should not leave this information behind. You should always take the cards with you, always destroy them. I first saw this floating around, was kind of interested in it. I actually investigated it when I was at previous employment, and the head of our executive protection force basically came up to me and said, hey, this email's going around online about not being able to leave hotel keys around because it contains personal information. Do we need to worry about this when the executives travel? I said, well, I have some ideas on it, but to test it, I need to buy some gear. And they said, well, how much would it cost? I said, well, reader-writer is about $200. So we need at least one of those to be able to test it. And they said, okay, great. Buy 3 of them just in case we break some. So, great part of being in the corporate security area is, $600 to a company is, not much. So with that kind of got me started in looking at Magstripe cards. And the reader-writers have actually come in very handy during pen tests, especially physical assessments, when looking at what's at cards or assessing kiosks that take input through cards. So to help look at this myth, we're going to first do a brief introduction to Magstripe cards. We can talk about what is a Magstripe card, how is data encoded onto the card, and those type of standards that go into it. Next, going to go over tools that can be used to read the cards. I'll talk about a free tool as well as a commercial tool and discuss some of the advantages to both of them. So folks can leave here and start reading their own cards. Also talk about the hardware required, since this does actually have a hardware component, talk about that as well. Talk about how I tested the myth, view the results, discuss the results, and then we'll move on to some advanced techniques. So what is a Magstripe card? Basically, a Magstripe in the classic term is usually made up of a bunch of ISO standards. There's one that defines the physical characteristics of the card, so how big it is, how the corners are rounded, how flexible the card is, where the stripe is located. The other ISO standard that's generally used outlines 3 tracks for the cards as well as coursivity. Coursivity is something you hear mentioned when you look at writers. There are basically 2 different types, which depends on how strongly the data is written to the card. For the most part, if you're just reading, it doesn't matter if it's a high-co or a low-co card. For writers, it's cheaper to come across low-co writers than high-co writers. But if you have a system which say you have a client that uses high-co cards, you want to forge them, you can forge them with a low-co reader, and the reader basically can't tell the difference between the 2 of them. The card will just get damaged quicker. Basically, a low-co card requires less magnetic energy to encode the data onto the card. So if it's an industrial environment, for instance, airports, Manufacturing plants, like automotive manufacturing plants, will use HICO cards because they're around a lot of big motors, a lot of equipment that puts out a lot of electromagnetic radiation that can mess up a Magstripe card. So a HICO card will be harder to mess up. So if you do make a low-code card for that environment, it'll just work for a day or two, then stop working, but usually that's all you need to get yourself in the door for a pen test. For more information on that, there's actually a post on my blog where I talk about it in more depth about what the difference is between HICO and low-code. There's also a series of posts I have, which I'm presently working on. At the end, there'll be a link to my blog, so if any of this interests you, go over there, check out the tagline for Magstripe Cards, you'll find out more information. The third one is how data is encoded onto, the third ISO standard is how data is encoded onto a financial services card. And basically, the banking industry, being the banking industry and coming up with standards, came up with standards with how data is encoded onto ATM cards. And basically, that standard has been adopted by the majority of folks in terms of how data is encoded onto Magstripe cards. Gift cards, even ID cards, a lot of those still use the same format set up by the banking industry. So despite the fact that it's banking specific, it applies to a lot of different areas. Now, here you can see on the card there are actually 3 tracks of data. The first track is the highest on the card, second track's the next lowest, and third's the next lowest. So it's key to remember there are 3 different tracks. And each track has a different format that is standard to them. Again, these are just based off of the ISO standard. Some manufacturers try to get tricky and develop high security cards, where basically they invent their own standard, or I've even seen manufacturers that simply just move track 3 to track 2. And a lot of stupid readers, the chip in them will only recognize track 2 data on track 2. So unless you get their proprietary reader, it won't work. So I'll discuss, of the tools that we have, how we can get around that. But for the most part, the first track uses a character set, which is basically a 7-bit character set, which covers alphanumeric characters and a couple special characters. There's the sentinel bit, which is a % sign. Then you have X amount of alphanumeric data. The up caret is the divider between the fields. You can have as many fields and up carets as you can fit into the 75 alphanumeric characters. Then you have a question mark, which signifies the end of the strip, and then LRC value, basically a checksum. So when you read the card, it reads in the data, computes a checksum. If the checksum matches what's on the card, you knew it read it correctly. Because Magstripe cards can be damaged, most of them have a checksum in there to basically make sure the card's been read correctly. Track 2, very similar. In this case, it just uses 40 numeric characters. Different grouping on the bit rate, slightly different special characters, but similar type of format. You have a sentinel bit, data, dividers, close, and then an LRC. Track 3, which is actually called the thrift track, developed for the thrift industry. Same type of thing as track 2, but just a lot more dense. So you can fit a lot more information onto a track 2 track. Because of that, it's not used as much because with the data being that close together, it's a bit easier to damage. But you will find cases where track 2 is used in some applications, and actually, track 3 is used in some applications. And oddly, track 3 is actually really popular in access control systems. If you find an access control system card that is a Magstripe card, most likely you're going to have track 3 data. Part of that's also done because most other cards don't use track 3. So a company might have a company card which has 3 tracks on it. The first 2 tracks are actually a company debit card, which they can swipe through the point of sales. You can buy stuff in the cafeteria or whatever. And a third track, which isn't used by the point of sales, is the access control system. So now we have just a general overview, a couple of different tools that can be used to look at the cards. The first tool is Stripe Snoop. The big advantage of Stripe Snoop is it's free. So you really can't beat on the price. Supports a lot of different operating systems, but it has some limitations. One of the limitations is it pretty much cannot parse non-standard formats. So basically, you swipe the card, and the reader that you need to make for this, or you can buy a reader that is compatible, the decoding of the strips is done inside the reader. So the reader sees the format and basically spits out the standard data format. So if you're trying to read a card that's written on some sort of proprietary system, unless you get a hold of one of their readers, you're not going to be able to read it because the card's going to be expecting track 2 data on track 2 with ABA character set formatting. So if they change away from the standard formatting, Stripe Snoop is probably not going to be able to read it. Other downside of Stripe Snoop is if you have 3 stripes on a card, you need to be able to identify, basically, unless you get a 3-headed reader, and if you do that, you're going to need to have 3 inputs into the computer. Basically, Stripe Snoop can accept input from parallel port, serial port, and if you have a game port for some god-awful reason still, a game port. So if you need to read data from all 3 tracks, you actually need to have those 3 interfaces hooked in, so it gets a little crazy in terms of having 3 inputs into your laptop. Or more commonly, you'll have this reader here does track 1, this does track 2, this does track 3. So you plug in the first one, swipe it for track 1, unplug it. Plug in the second one, swipe it for track 2, unplug it. Plug in the third one, swipe it for track 3, unplug it. A little time consuming if you need to go through 50 cards. But it's free, it gets your job done. It also has a really neat ability. It has actually a database built into it that'll try to identify the type of card being used. And if you can identify it, it'll then tell you this is a driver's license, this is a credit card, and it'll actually parse the data on the card based off of that information. And I have some information, some screenshots of that coming up. And that's a kind of neat feature in terms of they detect some student IDs, some other information. So that's a cool little feature of it. Reader options, you can either build your own. Basically, if you go to any of the cheap electronic warehouses, buy a TTL card reader, which are usually like $2-3. Get a TTL to serial or parallel converter, plug in your computer, you can read it that way. Or a lot of point-of-sale keyboards that are out there, Stripe Snoop is compatible with as well. So there are some cheap build options if you're DIY, or you can buy a pre-made reader for $50 off of eBay. Some of the track information that we see here, this is a card that I swiped, which is actually a credit card, or this is a driver's license. Because it's my driver's license, I blocked out some of the data for some odd reason. So goes through, reads the data, it shows you the raw output up here, then it shows you actually what the card format is, and it's based off of, you can see the start sentinel, divider, and then it tells you it's possibly a North American driver's license, and then it parses the data. So it knows this number here means state of Ohio, license number, date, and sometimes the date format switched around, like the date is actually year, month. So it helps parse it out for you, which is pretty cool. Here's an example of a credit card. Actually does a similar type of thing, parses it out. So the database feature is pretty cool. If you come across a card you're not sure what it is, you can swipe it. If it's in the database, it'll tell you. One thing is the database is fairly outdated. It hasn't been updated in a number of years, but still a pretty cool feature, and it's free, so you really can't beat the price. Magstripe is the commercial tool, which I use, highly recommend, but it is pricey. It's about €200, which, depending on how the euro and the dollar is doing, can change. Right now, luckily the euro is actually tanking, so the conversion rate's getting a little bit better. About a year ago, when the dollar was into crapper, the price on these was pretty high because it was almost 2 to 1 dollar to euro. This is a USB device. It is a reader-writer. The older versions use a parallel port. You'll be able to find them on eBay if you can. The parallel port versions work just fine. That's actually what I use myself. They support NT, Windows 2000, Vista, all sorts of different stuff. They even support Windows Mobile, and it provides code on a site to write your own Windows Mobile client. It can read all 3 tracks at once, and the really neat feature of the card is the reader basically reads the data off the track and sends the raw data to the software. So the software can show you the raw output. So if it's a non-standard format, you can get that data from the card and begin to analyze it. So you can analyze non-standard formats with Stripe Snoop pretty easily. It also has some pretty cool data analysis and visualization tools I'll talk about later. Other really cool feature, it's a card writer. So if you get a card, you want to modify it, want to make your own cards, this device can do it. It also has some neat features to automatically regenerate the checksum. If you start manipulating a card, regenerate the checksum, so it'll still be valid when it's read. In my opinion, it's the best reader to look at for non-standard card Magstripe reading. If you're going to do anything with it professionally, it's well worth the price. Excellent product. So a couple of examples. Here's a binary decode. Basically shows you the binary data and just does a straight parsing of the tracks by the standard format. Tell you the character set being used, if the LRC values match up, if the parity values match up. Same card in character format, or basically parses it down by the character set, and then it will actually break it down by the ISO set. So a couple different ways to decode it. For custom cards, the binary format is very nice, but it's fairly flexible in terms of how it can display data. And as I mentioned, it also has a writer, which is really awesome when you get into actually wanting to manipulate these systems. So now you know how we can read the cards, talking about testing the myth. For this, I grabbed approximately 25 hotel keys. If anyone's interested in the data, I can probably put up online later. You can email me about it, or I can put up my blog if there's enough requests for it. I grouped the cards by hotel and room number. So that way we can look at 3 cards from the same hotel for the same room, or 6 cards for the same hotel, 2 for each different types of room, to see what sort of patterns there are. Read the cards multiple times, because one thing I started to discover is that the character set's not standard, so there's no checksum that lined up. So basically I'd swipe it multiple times, and if I got multiple reads that were the same pattern, I was fairly certain it was reading correctly. That's also why I limited it to 25 cards, because I was swiping each of them a couple of times, like 3 or 4 times. So after swiping about 100 card swipes, it just starts to get old. But limited down to 25 just for representative sample. And then we started to analyze the results. So here's the first example. We don't really need to look at the data, but just to show you, again, this is on track 3, unknown format. In this case, a bunch of binary data because it can't actually parse it. Another example, track 2. And we have a third example, which is on all 3 tracks. And we'll be coming back to this one a little bit later. But the vast majority of the hotel keys I looked at, all the data was on track 3. Very few had data on track 1 and 2. So next, started to analyze the results. First thing I saw is that every single hotel key had data on track 3. Some had data on additional tracks. As I mentioned, some data was encoded between multiple tracks. In most cases, if it was encoded between multiple tracks, it looked like the same data coded across 3 tracks. Not a standard character set. Wasn't anything that was alpha or BCD, so none of the standard ISO character sets. I tried a bunch of different groupings to try to get a valid checksum, so tried different bit groupings and other things and tried to generate a valid checksum with valid parity bits. Was not actually able to do that. And the interesting thing I found is that the data varied greatly between 2 cards, even for the same room. There was one exception. I actually found 2 cards for the same room that were off by just 28 bits. So most of the cards, if I looked at them for the same room with 3 different cards, very, very little was similar. So there's some sort of encoding, or I hate to say encryption because knowing the products here, probably not any sort of strong encryption, but there's some sort of really funky encoding going on here in terms of the data. Next up, let's look at observing the process. When we go into a hotel, there are a couple of different things that you'll notice. Talk to a number of hotel staff, and there tend to be 2 different systems. There's an old system and a new system. Old system is actually just a keypad that's not attached to anything, and when they swipe your card, they basically type in the room number and the end date. And then they swipe the card through, and that card is now activated for that room to that end date. Newer systems, it does hook up into the PC, so the employees are not really sure what data was sent to it. But it's pretty clear from the old system that there wouldn't be personal data on there because they're just entering in room number, exit date. So looking at the results, from looking at the data itself, we see that, 1, the data is not readable in any standard format. In the email, it says you can swipe it through any reader and be able to read it. That's obviously not true because it's not even a standard format. So that begins to debunk the myth, because if you can actually read the data off of it, that would kind of be the first step. Second, the email claims that it stores things like your home address, your credit card number, your social security number. Frankly, more data than these cards can store. So that also leads you to believe it's not correct. And also, if you look back at the data, even if you just look at one of these tracks, these are actually all the same. There's only finite data you can store in there unless you're using some sort of crazy compression algorithm. And then looking at the process, it looks like the information is just being entered in by room number and leave date. Final thing I did, consulted Snopes, and they basically said it was false. So based off of these things, I basically feel that this is busted. Isn't any sort of personal data on those cards. Not to say somewhere out there there isn't. For instance, I wouldn't be surprised if like Disney World for some odd reason would actually put data on the cards because they like to track everything about people, or a casino wouldn't. But the average hotel definitely isn't storing personal data on the card. And if they are, it's not in any sort of standard format. So, you can leave those cards, you can take them. Interesting story of something that led into why this myth was potentially perpetuated is in Las Vegas, they were busting hookers. And they noticed the hookers had on them like 50 hotel room keys. And they expected that these hotel room keys were just, for, business expenses. But they started to look at the hotel keys and notice that a couple times they were busting them, they were using them as credit cards. And they go up to a pump and basically pay out a credit card. And ends up what they were doing is there was folks in town that were stealing credit card numbers, and then instead of encoding them onto credit cards, just encode them onto room keys because it's the same exact format. You can still encode the data onto it because hookers have lots of extra room keys. So in Vegas, there were hookers running around with hotel keys with credit card numbers on them, but that wasn't because the hotel was putting it on there. It was just a nice way to commit credit card fraud. So that's a potential for how this myth got perpetuated. But for the most part, pretty much busted. So with that, we'll move into some more of the advanced techniques, which is where it gets fun in my eyes. Stripe Soup has some signal analysis techniques where it actually show you the data that's on the card. You can do your own groupings where this you can highlight it. It'll tell you what the character set is. If you can have a writer can modify it. Nice to be able to look at custom data sets and be able to pick out patterns, try different groupings. It's a nice visual representation of the card, which is helpful for signal analysis. Additionally, on the card, on the reader, you'll see this window over here. This is actually the tick number to duration. And this can actually be handy for looking at how the card is encoded. Most cards you're going to see are going to have 2 lines of some sort. And that's going to be encoded in the standard MFM format. There are basically 2 ways to encode data onto a card, MFM and FMM. If it's 2 stripes, it's MFM, and pretty much any reader writer can read and write that card. There's a company in Germany that makes cards that are FMF. If you see 3 strips, that's the case. Mackie Interface can read these cards. They can't actually write them. But you might encounter these on access control systems. Some vendors use that as a copy protection mechanism of sort. You can also start looking at the cards. You want to see 2 fairly close stripes. If you start to see ones that are starting to diverge, or here where it almost looks like 3 stripes, and that card got exposed to some sort of magnetic field, which is throwing off the tick rate. So that card will probably take multiple times to read. So it's kind of a neat little thing. If you're doing a sort of troubleshooting on a system, you can read the card, figure out if the card is or isn't working for whatever reason. Data analysis engine. This is handy for non-standard formats. You can basically start doing different parity and grouping. It'll automatically run the checks. If it comes back as all parity green, you found how the character set is grouped. You can start then doing some manipulation. When I do a lot of analysis, I actually just have some Perl scripts I run that parse through all different combinations because it's really boring to sit here and do each pull down, hit go, pull down, go. Just have a Perl script that runs through and does it. But it's a nice way to be able to, again, if you have a custom card, you want to figure out the format, you can start to figure out how the characters are grouped and manipulate stuff. Another neat feature, there's a graph at the top that basically shows you where each track is written. You see you have track 1, 2, and 3, different colors. This card up here, their tracks are written at basically the same time. So when you read them, the data is coming in at the same rate. This card down here has tracks written at different times. So this implies that either that card is used in a rewrite fashion. For instance, most cards just have a reference number on them. So when you go to a Subway and swipe them, it just queries the backend system, says, does this person have money on the card? Yes, and lets it go. Other cards, when you swipe, it'll actually rewrite it on the fly. So if you see multiple writes, it's a sign there's some sort of rewriting on the fly, especially if it's not a nice smooth line. That was probably someone swiping it through. If it's a machine-done one, it's going to be nice and smooth. So I can tell you how it was rewritten. Also, if you see multiple stripes, it's a sign that potentially you have 3 different systems in play here because they were written at different times. So again, handy to start figuring out what's on the card, how that information's gathered, and where it can come into play. Something I recently started playing with is a product called Magnetic Developer. Really cool stuff. Pretty expensive though. It's $44 for a little 2-ounce bottle. But it's a little dropper, and basically when you put it over the card, it visually displays the data on the Magstripe, which is pretty cool stuff. And then when you're done, you can either just wipe it off, the card's reusable, or if you need to store it, you can put, a lot of people I see use packing tape. They put packing tape over it so you can still preserve the pattern.
Question over here.
Yeah.
You can do that with fine iron filings, which is more like $1 a pound.
Yeah, good tip. So yeah, so find some fine iron filings and that would work far better.
Are results pretty though?
I don't know actually. I have not tried it. Are the results as pretty? Probably depends on how fine the filings are, but I would be willing to bet that's actually all this stuff is. It's basically stored in, you shake it up, it's some sort of filings inside of basically a fluid that dissolves really fast. So you pour it on and it basically dissolves and leaves the filings behind. Here are some examples of the different cards. You can see the little stripes here. This is a 2-track card, 1-track, so on. We'll take a look at them in a little bit more depth. Here's one wide track. Remember one of the cards we looked at before had data on all 3 tracks. This is actually just one really wide track. 2-track card, and actually if you zoom in on it, you can get a fair amount of detail. I haven't tried, but you could probably start to decode that by hand if you were really that anal. But helpful just to see what's on the card. Also, can be useful to see if a card's been damaged. And then here's most of the hotel keys are actually just half a card, which I thought was kind of interesting. The strip doesn't run the full length of it. Also, you can see if a card has been rewritten multiple times. You can start to see where the tracks kind of overlap because they don't always rewrite the exact same area. So that can be handy, again, if you're looking at a card that's been rewritten. You can get some clues visually from that as well, besides just looking at how the tracks are written to the device, to the card. Okay, so some applications of this. A couple of places I've used this called penetration testing. One big one is access control systems. There are still people that use Magstripe cards for access control systems. If you can get a hold of one of those cards and read it, then you can start to manipulate that card and potentially be able to gain access to the building. A couple of interesting things that I've seen. These are just general formats because each system runs a little bit differently. I didn't want to take a card from an actual system I used because some of them, information was gotten through NDAs and everything, so can't necessarily release them. But you'll see a general format like this. You usually see a site number and a badge number, and this is for a centrally managed system. So there's some server at the company that when you swipe your card, the reader talks to a central server or has a database on it that basically says this card number can or can't get into this door. For the most part, you have a site code, and then the badge number is unique to the user. So if you get a hold of someone's card or get their site code, you can then start making your own badges. You can replicate the badge that person has, but let's say you get a low-level person that just gets access to their front door, you want to get access to a data center. If you have a lot of time, you could start fuzzing the badge number, basically just trying other people's badge numbers. For the most part, the site code does not change between systems unless you had some sort of strange merger of 2 companies. So the badge number is something to focus on there. You could also look at things like using a lower down badge number, because generally, especially if it's a new system, they're going to issue the guard and administrative badges first, then the higher up ones. For standalone systems, where it's just basically a card reader on a door, doesn't really talk to anything, you generally see a format that looks something like you have a site code again, a building code, an access code, which could be a room code or just code 1 gets you into these doors, code 2 gets you into these doors, activation date and end date. With this, you can try modifying different values. You know what the different values are. But if you know building, you want to get into this building over here, that's building 4, you can try that. But something I found in some of these systems that works, which is kind of cool, if you change them to common wildcards, like 255 is one that I've seen used a lot, 0 and 1, they basically act as wildcards. So get a hold of a card at a site. Basically, we don't touch the site code because that's the same. And we change the building code to 255, the access code to 255, and it now works on every single door. So that's kind of fun. Then you don't really need to change around the activation date or other things. So something to try out if you do get a hold of one of the cards in the format. Try changing them around. So you try those common values of a 0, 1, and 254 or 255. And you'll be surprised some of the systems that actually do allow you in. If you're interested in access control systems with Magstripe readers, I'd recommend checking out this white paper. Basically a thesis that some folks did on attacking card systems. They especially made a neat little device, which basically plugs into the reader. There's a picture of it. Goes to a little handheld to basically tell it the card number and just spits it in so you don't need to rewrite the card. One of the research projects I would like to actually try to build one of those, but keep posted on that. But if you're interested in this stuff, highly recommend reading this white paper. They give some information on how those systems work, potential weaknesses, and ways to attack them. The other area that I've used these cards is in looking at kiosks. So a lot of companies are going over to kiosks, and if they take any sort of input from a Magstripe writer, sometimes you can elicit interesting results by feeding the Magstripe writer data it's not expecting. Because some programmers today know that you should sanitize all inputs that's given to the application, but even when they sanitize stuff from the keyboard and other areas, I've found some cases where they don't sanitize inputs from the Magstripe reader because they're thinking, well, who the heck's going to provide any sort of garbage data through there? So some interesting formats to look at. One, actually making cards with longer tracks. You can actually start splicing cards together. So you get something that's longer than the normal character set. So in track 1, more than 80 characters. Track 2, more than 40 characters. Track 3, more than 107 characters. And I've seen some cases where you can do this. It's a swipe through type kind. You swipe it through, the machine crashes. So definitely something you're going to want to look at in terms of, are you doing a buffer overflow? What sort of instability is being caused in this system? Additionally, I've had some luck with mangled card formats. A couple of things that I try in my list of kind of standard check cards I have. Just come up with some crazy formats, make these cards, keep them in your set, try them when you're looking at a kiosk. The first one is just a start bit and just a ton of divider bits between different sections. Contains no data, see how the application responds. The second one's one I've actually had some luck with, where I've seen some applications where it has a sentinel bit that does the caret, has data, caret, and then the field divider. And I found if you just do the caret, so the application's not expecting data, and you close it off, you can really confuse something and have caused, again, some stability issues, which shows a sign there's something going on. In most of these cases, in fact, in all the cases, we never really looked at making actual exploits on the cards. Because a lot of times you're really doing it blind, you run it through, it crashes. So it's just something to bring back to developers of saying, hey, you're not sanitizing input here where you could crash the device. They usually work on then sanitizing that input and fixing it. But interesting area to check into when looking at kiosks and other devices. Another interesting thing is adding fields onto cards. If there's room on the Magstripe strip, add in some extra data, see what happens. So fuzzing cards, interesting thing we do a lot of looking at kiosks or other formats. And with that, my laptop. Oh, there we go. So with that, we'll basically take it on to questions. Folks have interest in secure state or need any assessments, check out our website. Next one down is my blog. I have some posts up on this. We'll be doing some more posts on this subject. Coming up, I have something in-depth post on Stripe Snoop. Then we'll be really digging into Mackie interface. And I should say I don't get any royalties from Mackie interface. They just make really awesome products. Additionally, if you want to play with smart cards, they have some really cool smart card products as well. And there's my email address. Yeah. Iron Geek.
Thanks, Matt. I have kind of an odd question. Most of these cards, or at least a lot of these cards, have a little tracking ID on it, and it checks to a back-end database to actually get all the real data.
Yeah.
It's basically there just as a placeholder. Have you tried doing any SQL injection using those fields?
I have. The biggest trick is you don't have a single tick. It's not a valid character on the Magstripe card formats.
Now, I may have missed it, but you were mentioning earlier that it's not like a common character set. What character set is it using? Is there any kind of name for the standard that it's using?
Yeah, so we'll go back to the... Okay, so depending on the track, we basically, track 1, alphanumeric characters, and then these are the special characters that are allowed. Then just numeric, here are the special characters that are allowed, and numeric, here are the special characters that are allowed. So there's no single tick that's in that character set. Most of the special characters that are non-alphanumeric are used for things like field dividers or start sentinels, end sentinels. It would be possible if they're doing some sort of very poorly coded SQL queries, for instance, I've seen SQL injection to a MySQL database where you don't need a single tick. You can just slap in, select in your statement, and it'll actually run it. So that would be a potential in these cases if the stars align just right. But classic SQL injection where you get a single tick wouldn't be possible because of the character set.
Okay, thanks, Matt.
Sure. Yeah, Roclan.
Hi, I have a question about the hotel keys.
Yeah.
You said you busted it because you can't swipe it through the reader and have it spit out all of your information. Did you ever make sense and parse anything out of the data that any of the hotel cards gave you?
No. That's something that's kind of, I got through that in terms of project time I had. Basically, just had to look at other things because when I do penetration tests, very few people pay us to break into hotel rooms. So the other stuff is stuff I can look at on work time where someone's usually paying me for it. But if I retire or win the lottery, that would be a project I'd like to look into because I would be very curious to know how that is encoded just because most of the hotel keys come from the same manufacturer. So if you figure that out, probably work on most hotels. So that would be a cool little project. And if anyone is interested in that, that'd be something that could be a good online project. Basically, people start gathering up hotel keys, sending the data in online somewhere, telling the hotel the room number, check-in, check-out date, see if anyone could break it. Major Malfunction actually did a talk on Magstripe analysis, and he actually referenced a specific format in that talk for hotel keys. I've yet to see that format anywhere in the States. Now, he's actually from Europe, so it might be that the system in Europe uses that format. But it would be curious to see what actually comes out of, if there's any way to decipher the format, because there has to be. These devices are, pretty crappy, little embedded devices that have very little memory. So it has to be something fairly simple. It's just a matter of finding time to look at it.
Thank you.
Sure. Think geek again, is there anyone else?
Slightly off topic to hotels, but still on the Magstripe subject matter. Have you done any looking into student ID cards that different universities use? Because nowadays they're using these cards for also paying for vending machines at the bookstore and all that.
Yeah, that's actually, have done some looking there. What I've found is that actually it's pretty common to have multiple systems. So for instance, track 1 might be the track that contains student ID number and other information that's used by the payment system. So when you swipe at the point of sales terminal, it reads track 1. Track 2 controls the general access control system for campus. So track 2 is read, and that'll open up the door to the building. And then track 3 is used by the actual get into your room. And you'll see that at corporate campuses as well, because a lot of corporations are going over to same thing as colleges, where you can go into cafeteria, pay with your ID. So there'll be actually 3 divergent systems that each have their own track on the card.
But usually it's not data you can manipulate on the card to actually change anything. It's still a reference ID that goes back and talks to a back-end database to actually find out the real data.
Correct. A key that most systems just have a reference ID that goes into a back-end system. A sign that you might have a system that's rewriting data is if you have a reader that sucks in your card and then spits it back out, especially if you have a system that sucks it in and shimmies it back and forth and spits it back out. That's most likely doing a rewrite on it. Because an actual rewrite on when you swipe something to read and rewrite it at the same time is a pretty difficult task. Because one thing, if you get Stripe Snoop or a Magstripe writer to write it, it does take some practice to swipe it at a constant speed. And most of the high-end ones actually have a motor that feeds it through at a constant speed. So if you had anyone that went up and swiped the card and you tried to rewrite it, if they did any sort of jerking motion or change of speed, it wouldn't rewrite. So generally, if you have a system that reads it and rewrites it, it's going to suck it in and then spit it back out to you, but that's fairly rare.
Thanks.
And I think there's someone else being hidden by the light.
Transit cards have Magstripes with usually a little bit different physical format. Do they use similar encodings?
I've actually done very little looking at transit cards because Cleveland has a public transit system, but when I use it, I don't use a pass. So I don't come across them too much. But I'm not sure what character set. There were some talks at Hope, I think 3 or 4 Hopes ago, on the MetroCard system that probably had some good data on it. But that's just something I haven't really looked at. Any other questions? Okay, no, thank you for coming out. And if you have any questions, feel free to come up to me later.